In today's video, we're going to find out how to calculate the empirical formula from the percent composition by mass. First of all, we need to understand the difference between molecular formula and empirical formula. So the molecular formula tells us the actual number of atoms of each element found in a compound. So if we use the example of benzene, it has a molecular formula of C6H6. The empirical formula, on the other hand, gives us the lowest ratio of atoms in a compound. So if we use benzene as our example again, the lowest ratio of atoms would not be C6H6, but rather CH, because we can divide both of the subscripts by 6 and get 1 to 1. So we can find the empirical formula for a compound by working backwards from the percent composition by mass. So in these examples, we have to assume that we have 100 grams of a substance. So the mass of each element would be their percent by mass. Our first example will be to find the empirical formula for a compound that is 88.8% oxygen and 11.2% hydrogen by mass. So we use this handy tool to help solve for the empirical formula. So this table helps us organize our information and then figure everything out. So we have our two elements. So we have hydrogen and oxygen. And we know that hydrogen is 11.2%. So they're in 100 grams of the substance, you would have 11.2 grams. And oxygen was 88.8. Now we need to go to our periodic table and find our molar mass. So for hydrogen, it's 1.01 grams per mole. And for oxygen, it's 16.00 grams per mole. Now remember, the way we find the number of moles is we divide the mass by the molar mass. So the first one, we would do 11.2 divided by 1.01. So I would get 11.09 moles. And then oxygen, we had 88.8%, so 88.8 grams divided by 16 grams per mole. And then we get 5.55 moles. Now the last step is to figure out what ratio we are working with. So we would take the moles of each one and divide it by the element that had the lowest mole amount. So for this one, it would be 11.09 divided by 5.55, and that would be equal to 2. And then oxygen would be 5.55 divided by 5.55, and that would be equal to 1. So therefore, our empirical formula is H2O. And that's how you solve for empirical formula. So now we'll work through a second example. Now we want to find the empirical formula for a molecule that's 69.94% iron and 30.06% oxygen by mass. Okay, so we'll fill in our information again. So we have iron and we have oxygen, and iron had 69.94% by mass, so that would be 69.94 grams in 100 grams, and oxygen had 30.06. So the next thing we need to do is look up the molar masses. So for iron, it's 55.847 grams per mole, and oxygen is 16.00. So now what we need to do is calculate the number of moles. So we would go to our calculator and put in 69.94 divided by 55.847. So that gives us 1.25 moles. And then for oxygen, it would be 30.06 divided by 16. And that's 1.88 moles. And now what we need to do is divide each amount by their lowest mole. So 1.25 is going to be divided by 1.25 because it's the smallest amount. That's going to be equal to 1. And then 1.88 divided by 1.25. And we're not going to get a nice even number this time. It's 1.5. So if you get a case like this where your answer doesn't work out evenly, you need to think of a number that you can multiply both by to figure out, to get a whole number. So if we multiply both of these numbers by 2, we'll get a whole number. So 1 times 2 is 2, and 1.5 times 2 is equal to 3. So this time, our empirical formula for this compound is Fe2O3. So we can use the percent composition by mass to figure out the empirical formula. And if we're given more information, if for some reason we also know the molar mass, we can actually use both of those pieces of information to find the molecular formula. So what we would do is we would figure out the number of times bigger the molecular molar mass is than the molar mass for the empirical formula is, and we multiply that number by the empirical number to figure out the actual ratio of atoms. So in this example, we find a compound that has 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. And we're also told that its molar mass is 120.10 grams per mole. So the first thing we need to do is find the empirical formula in the same method we've been doing. Then we need to find the molecular formula. So the first thing we need to do is write down the three elements. So there's carbon, hydrogen, and oxygen. So you see there's 3 this time. And the mass in 100 grams would be 40.0 for carbon, 6.7 for hydrogen, and then 53.3 for oxygen. Now we need to look up the molar masses. So the molar mass for carbon is 12.01. The molar mass for hydrogen is 1.01. And the molar mass for oxygen is 16.00. So we can now find the number of moles by taking the mass of each and dividing by the molar mass. So for carbon, it's 40 divided by 12.01. So that's equal to 3.33 moles. 6.7 divided by 1.01 is equal to 6.63 for the hydrogen. And then 53.3 divided by 16.00, so that's 3.33. So now what we need to do is divide by the lowest moles. So this one would be 3.33 divided by 3.33. That's going to be equal to 1. This one's 6.63 divided by 3.33. And that's going to be equal to 2, pretty close, 1.99, so we'll round it up to 2. And the last one is 3.33 divided by 3.33. That's equal to 1 as well. So now our empirical formula is CH2O. So we've got that now. So now we need to solve. So we know that the molar mass of the compound is equal to 120.10 grams per mole. We know that the empirical formula is equal to CH2O. So what we first need to do is find out what the molar mass of the empirical formula is and see how many times bigger the molecular compound is, the molar mass of the molecular compound is than this. So the molar mass of CH2O is equal to 12.01 for the carbon plus 2 times 1.01 for the hydrogen plus 16.00 for the oxygen. So let's add that together. So 12.01 plus 2.02 plus 16.00, that's 30.03 grams per mole. So the next thing we need to do is figure out how many times bigger the molar mass of the compound is than the molar mass of the empirical formula. So that's going to be our N value. So N equals the molar mass of the compound divided by the molar mass of the empirical. So we have 120.10 grams per mole divided by 30.03. So that should be, I'm looking, it looks like it's going to be 4. And sure enough, 3.999, so equals 4. So N is 4, so that means that the molar mass of the compound is 4 times bigger than the molar mass of the empirical. So now we need to times the empirical, everything in the empirical formula by 4. So the molecular compound is equal to N times the empirical, so CH2O. So it's going to be 4 times CH2O. So it's going to be C4H8O4. And that is the molecular formula.